Hello, my name is Colin Greatwood. I'm a mechatronics technology engineer with Festo, and today I'll be showing you how to set up a Festo CMMT stepper drive and motor with Modulo Mode and output a position trigger at a specific point in the 0 to 1 revolution Modulo Mode. A quick overview of the hardware. You can see on the left side of the screen I have a CACN 120 VAC in to 24 VDC out power supply that is powering the CMMT stepper drive in the center of the screen. This is a multi-protocol version, and you can see that I have the EMMT ST single cable stepper motor attached via the one cable. Transitioning over to Festo Automation Suite, you can see here that I have extracted the project archive associated with this video, and I am scanning here on the main scan tab. I refresh my screen. You can see I have one drive. If I click Add to Project, you'll see that drive here on my home page. Now, double-clicking it, I'll enter the plugin. I'm going to be showing you the few settings that you need to set up modulo mode and position trigger to see that digital output go high at a specific point in the revolution. The settings that I'll need to do this: first, I'll expand the Axis 1 group, go to Close Loop. You can see that I've configured my application mass here, which, as you recall from the video, I only had a little piece of tape attached to the axis, so I have a very small moment of inertia. I'm just going to calculate my closed loop parameters, store them to parameter set 0, and we're done with the closed loop. Next, I'll go to digital I/O, and since I want a digital output trigger to be going to another device, say this is a camera or some tertiary application that's on the side of a rotary indexing table or something like that, this will output a physical digital out signal at connector X1A, pin 9 or 10. I'm going to use 9 here, and I'm going to use position switch 0 or setting 9. That's all we need to do on digital I/O. Next, we'll go down to modulo mode, and we're going to set up modulo mode's parameters here. Requested modulo mode will make shortest path, and my modulo value, I only want it to go from 0 to 1. So this means I'm going to go from 0 to 1 revolutions, and instead of continuing from 1 revolution to 2 to 3 to 4 to 5, it's going to go back to 0 each time it turns over. So 0 to 1, 0 to 1, 0 to 1. I'll show you what this means in a moment. Next, we go down to position trigger 0. It defaults to an active. We are going to set this up for automatic, or option 6, and we want to make sure that our position trigger source is set to encoder 1. Notice, because we already configured the digital I/O pin 9 at connector X1A, that it auto-populates here to configured output. Additionally, if you don't already have it, you'll need to add a position switch. I'll delete it just so I can show you how to do it. Click New Position Switch. I want to have this digital output go high or low in either the counterclockwise or clockwise direction. So I'm going to say position switch on/off is managed, and in the negative and positive directions. Now, these two set points on the bottom, X1 and X2, are the points at which, if I'm going clockwise, when I hit X1, it will turn on. I want that to turn on at 0.4 revolutions every time. And then I want it to turn off at 0.6. And if I was going in the reverse direction, counterclockwise, from 1 revolution backwards to 0.6, it would turn on, and at 0.4 it would turn off, etc. So I'll apply that position switch and leave all the rest of the settings in the left-hand diagram as defaults. Lastly, I have to set up some record table records to create a sequence. Click Add Record Set. I'm going to title this first one Ramp Up, so we want to come up to speed first. This will be a motion task of type velocity, and I'm just going to try and achieve a target velocity of 120 RPM. And I'll leave the acceleration and deceleration at 3,000 and jerk at 9,000, 90,000. I'll apply that record set. Let's create a second record. This one is going to be titled Triggering, so my triggers will occur after the ramp up. I'll go to Additional, Position Trigger, Mode, Automatic, Instance 0. This instance refers to which position trigger I want to reference, and since we've already set up position trigger 0, I'm going to leave that at 0, and it'll update immediately per the position trigger settings we've already created. Now I have those two records. I want to transition immediately from record 1 to record 2. And I want to do that when the target velocity is reached. I want no delay, and I'll be going to record 2. Now that I have all the parameters that I want configured for the drive, and this will allow me to initiate that digital high at 0.4, digital low at 0.6, going clockwise. I have configured a trace here that's going to record the actual value of the encoder, the actual value of the modulo, so that 0 to 1 value, and then the value of the position switch and the position switch value output at the physical connector to your PLC or tertiary application or your camera. I'm going to record that for a very short duration, which will show me a few cycles, and that will start right away as soon as I initiate my record table motion. So I'm going to connect and download all those parameters. I'll store on device and reinitialize as well. Great. Now I'll go over to my control, and you can see that I am not referenced currently. So I'm going to pull my plugin control, enable the power stage, and you can see that I currently have the flag on my motor set to the up position or towards the top of your screen. So I'm going to set that as my 0 set point by clicking Start Homing. You can see I'm now drive referenced. And if I jog forward, which is clockwise, that's 1 revolution on my encoder and 2 revolutions on my encoder. You'll notice at the bottom of my watch table, you can see that even though my encoder is at 2.5 revolutions, that my actual value modulo is between 0 and 1 as promised. So when I get to 3 revs, it turns over back to 0. I'll return to 0. Still from the control tab, I'll click record table on the control pages on the left, and I will start my trace, which is going to wait for motion to occur, and press play. After a few seconds, you can see that I get a record, a new record. I'm going to stop my motion. I'll go to the diagnosis tab, trace display, and you can see I have a new trace. Going through the trace, you can see that the actual encoder channel goes from 0 revolutions in about 2.5 seconds to about 4 revolutions total. It's a pretty short trace. You can see I'm hitting at about 2 seconds on the bottom of the screen, and I get about 4 revolutions done. In that same period of time, if I enable the modulo output, you can see that when my encoder reaches value 1, my modulo is at 1. But when my encoder value reaches approximately 2, my modulo is reaching 1 again. So you can see this resets to 0 and goes to 1, resets to 0, goes to 1 on the black channel, resets to 0, goes to about 1. Now, as I mentioned, I wanted to output a digital high and then digital low to initiate a trigger, a physical 24-volt command to some other device or some other process. And you can see that as my modulo approaches 0.4 revolutions on the black channel, when I hit 0.4, you can see that my position switch 0 goes to value 1. And it stays true until I hit that 0.6 value where it goes false. And it does this on every revolution, as you can see here, comparing the black and red channels. Just for good measure, you can see the red channel we were just talking about, the actual position switch. And if I enable the physical interface for X1A, which is a combination of all of those inputs, you can see that that value is going true and false. You can see this is not only internal to the drive, that it is being output to the digital output, which can be used by your other application. If you have any questions on how to set this up, modulo mode or position trigger, please reach out to your Festo representative. Thank you for your time.